0 divided by 0. 0 to the power of 0, and 0 factorial. But first, a little warm-up. Take out a calculator and try this, and that, and the other guy. Or just let me do it for you, entering in the numbers here, and entering in the numbers, entering in the numbers here, and entering in the numbers, and 3 strikes, and I'm out. One more quick thing. Y equals mx plus b. And setting the intercept to 0, everywhere on this line, y is equal to 2x, or y over x is equal to 2 at all these points. You believe me, right? Everywhere on this line, y is equal to negative 1/2 x. So y over x is equal to negative 1/2 at all these points. Good. Bad, because 0, 0 is on both of those lines, which means that 0 divided by 0 is equal to 2, and also equal to negative 1/2, and also equal to anything else. And we are okay in general with multiple solutions. For example, x squared is equal to 1. That's true for 2 different solutions, for x is equal to plus 1 and minus 1. But infinite solutions, that's undefined. See this? A could be anything. What about this problem? What could B be? Nothing. No possible solution. Another sort of error. And my calculator agrees 3 divided by 0 is error. But Google doesn't, which is scandalous. Because Google's scientific calculator, and plugging that into the search bar, they give you different answers. And where did that infinity come from? It came from another graph, not this kind of graph, this kind of graph. And we want to find 3 over 0. So we will let y equal 3 times 1 over x, and then we'll forget about the 3 because who cares about the 3. And we'll look at this graph as x gets closer and closer and closer to 0. And as it does, y goes to infinity. Or does it? Don't forget there are 2 different directions from which you can approach 0, from the east as well as from the west. And I ask you again, what value does y have when x gets closer to 0? We don't know. But then we return to 0 divided by 0, because if there's one guy who is not afraid of any big numbers, it's 0. 0 times a billion, 0. 0 times negative a billion, 0. So why can't this be 0? Well, we go back to the graph, and let us take y is equal to x over x, and see what happens when we let these 2 x's get smaller and smaller and smaller. And it would always equal 1, so we've just proved that 0 divided by 0 definitely equals anything, or 0, or definitely equals infinity, or negative infinity, or definitely equals 1. Or maybe it's negative 1, because don't forget, there's 2 different directions from which we can let x equal 0, or x get closer and closer to 0. And those 2 different x on top and x on the bottom, they don't have to necessarily be exactly the same all the time. X on top could be coming in from one direction, and x on the bottom could be coming in from the other direction. So it's possible that x over x is equal to negative 1. Or how about this? They're coming in from the same direction, but not in exactly the same way. One gets a bump. This delta is giving one of them a little bit of a bump. And what happens then? It diverges. And think about it. When x gets to down, we were letting x get closer and closer to 0. So eventually x is going to get down to the same size as this tiny little delta. And when x gets down to the size of delta, we get a 2. And when x is less than delta, things get scary. And this divergence here, this is what convinces me that 0 divided by 0 is really is undefined. So we stated the problem as generally as possible. We turned on our engine and a grain of sand blew us up. So I'm comfortable saying 0 divided by 0 is undefined. I'm in that club. The only problem is no one really cares about my comfort or wants me in their club. Moving on now to 0 to the 0 power equals 1, which we can clearly see by taking x to the 0 and letting x get closer to 0 from either side. It always works, except when it doesn't. 0 to the x. Even as x gets smaller and smaller and smaller, it always equals 0. So is the answer 1 or 0, or is it undefined again, or it gets worse? 0 to the negative 1/2. What's that? That's equal to 1 over the square root of 0. Well, we know the square root of 0 is 0. So what we have here is a catastrophe. Yet this does not bother me too much at all, and I will tell you why. This is why. Letting both of these two x's go to 0 from the right. This is what happens. Or we will let this x go to 0 from the right, and this x go to 0 from the left. Two paths to the same one answer. Get it? And if you're wondering where those functions reach their minimum, I'll talk about that at the end. And even if we give those x's a nudge, that's still okay. Even when the delta is bigger than the x and the x gets really small, that's still, everybody's still okay. But I'm only talking about half the situation here, because what if this x, what if this base x gets negative? Well, again, according to my calculator, negative 0.5 to the 0.5 is an error, but it's not infinity. It's not undefined. It's complex. Remember this guy from the earlier video? That's right, he had a magnitude and a direction on the complex plane. Can zoom in the complex plane and we can nudge it around with the delta function. You see what's happening here. We are still coming into 1. We are coming into 1. We are landing at 1, or you could call it 1 plus 0i if you wanted to. The I term is going away. We're happy with that. We know that cosine is an even function. We call that even. We know that sine x goes to 0 from the left or from the right as x goes to 0. So we're happy about this. And again, we are looking at 0 to the 0 power. We can move in from one side, from the other side. We can zoom in. We can nudge it. So let's take a vote. 1, 1, 0, undefined, 1, 1. All right, we tally up all the votes, and 2.5 cheers for 0 to the 0 power equals 1. And the awesome part about this is that not everybody agrees. And if you don't believe me, go to Wikipedia. 0 to the 0 power is a mathematical expression with no agreed upon value. It means different things to different people, which is awesome because mathematics is neat and fun when you don't just have to memorize the correct answer, but when you understand the arguments, the reasoning, when you see things from different point of view. And that's something to get excited about. 0! Instead of calling it 0 factorial, we should just shout 0 factorial. Should we define this to be 1? Are we just defining these things now? Because if it's just a definition, let's define 0 factorial to be Batman or pi. And why do we choose 1? Well, symmetry? Well, I got symmetry for you right here in this graph. Wow, factorial is really steep. It's even steeper than 10 to the x. And think about it this way, going from 10 to the 31st to 10 to the 32nd, that just means you multiply by 10, but going from 31 factorial to 32 factorial, that means multiplying by not just 10, but by 32. A calmer graph here, we have 3 factorial, that's 3 times 2 times 1, that's 6. 4 factorial, 4 times 3 times 2 times 1, that's 24, that's off the chart. 2 factorial is 1, 1 factorial is 1, and we will play now a game called Find the Function. This is an estimate. This is a winner. And we'll pause here for just one moment to convince ourselves that this new function gives us a value of 0 factorial equals 1, which it does. Remember, 0.5 factorial, it's a thing. Texas Instruments might not know about it, but Google does. What kind of thing? It's a solution to this crazy, complicated gamma function here, but I'll tell you something here. Multiply 0.5 factorial by 2, then square it. Hello! Black Pen, Red Pen has a video about this if you're interested in the details. Because I'm not. Because I'm done. Oh wait, I said we'd take the derivative of this first. So let's do that. Let's choose one of them. Let's choose this one. The other one would be fun too. Observe this, which is also kind of interesting, something you can prove to yourself. Where's the minimum? It's about at 0.35, somewhere around there. Ready. Rewrite. Differentiate. Product rule. There's this. There's that. It's equal to 0. Plug in, and we agree that this matches up, and I leave the other one to you as an exercise. Thank you for watching.